Hello and welcome back. Today we're going to talk about the basics of modeling a digital twin in LINQ. But first, let's have a quick review of digital twinning, because that's what we're ultimately creating, a digital twin of your organization. So what is a digital twin and how do we go about doing this? Think of IoT on your network devices. Sensors from devices in the field send real-time data on the performance of a device. Then a digital twin of that device modeled in software can take that data and simulate various scenarios, supporting network planning and preventative maintenance activities. Building on these ideas, what we're talking about today is the concept of a digital twin applied to your organization, to the business itself. This includes the people, the actions they take to deliver value, the systems they use, the information they create and/or use to generate business value. Taking this approach in your business can help to ensure your change and transformation programs are successful. Modeling the digital twin of your operation is the new way to ensure future business success. LINQ's super-fast modeling environment can be used in real time. Building the model of how your people, processes, technology, and information work together to create business value is really simple. In workshops, we work with you to convert your narratives about how you do business into a digital model. Now, this is where it starts to get just a little more sexy. To create a digital twin of your organization, we use a platform called LINQ. Now, LINQ is what you would get if you took, say, Visio, business process analysis, Tableau reporting, and had a digital baby. Another analogy, if Visio and other BPM tools are CAD, LINQ is GIS. It also has a back-end database where we store data about the information, actions, systems, and people that are required to drive business outcomes. Also, we store and calculate the relative value of each and every piece of information in the flow. LINQ is an information flow modeling tool that you can use to create a digital twin of your organization using only 4 simple objects. The information asset that drives your outcomes, for example, an invoice drives the desired outcome of getting paid. Actions that create information, such as printing an invoice. People that perform actions. An accounts payable clerk creates an invoice. And systems that enable the whole process, such as the invoicing system the clerk uses. At the heart of this model is the notion that an action creates information, which supports a subsequent action, which creates more information, action, information, action, information. You get the idea. This is the information supply chain that connects sources of data to the information outputs that ultimately deliver business outcomes. Building a current state model in LINQ is a very hands-on process, and it requires input from all the subject matter experts in the area to be modeled. So you'll need to carve out some dedicated time and get everyone in a room so that our experts can interview them and make a current state model in real time. But before we jump into modeling, let's have a quick introduction into the way you can assign relative value to information outputs in LINQ and what that means. Every LINQ model ends with the achievement of one or more business outcomes. The point in a model where business value is created is at the information outputs that support the business outcomes. LINQ uses a relative value index with a value between 1 and 10 to represent this. It's up to the users of the system to determine the value of any information output. These values are then cascaded and aggregated upstream from the business outcomes, illuminating the data elements that are highly valuable within the organization. The scenario we're looking at here is the design process for a large electric utility. We begin with the request of service through turning on the customer and getting a bill out. During a workshop, we start by talking about the outcomes of this process and the information outputs that support those outcomes. Notice that the information outputs that support these outcomes could be an application, a file, it could even be an actual piece of paper or a service. Each of the outputs is assigned a value. In this case, all of these are assigned a relative value. A paper map has a lower value than, say, the customer contract or the customer account because the customer account you need for billing, so that's absolutely the highest value. In this scenario, we're going to focus on the new service construction complete outcome. In the workshop, we start by identifying all the desired outcomes of the process, the information assets that drove those outcomes, and the relative value of those information assets. Once we've done this, we can build a complete model of the process from the first step all the way through the desired outcomes. For example, we could add an action under the paper map called map printing. And let's say it's done 1,000 times a month and it takes 15 minutes to do, so we add that through the properties. You want to remember to turn on the value and the cost so that you can see those on the sketch. The people performing the action are contractors, and we call them a printer contractor, and their hourly rate is, let's say, $100 an hour. Now you can see the cost associated with the action here. Now let's add a system, which is a printer. Since the frequency is 1,000 times every month, you can see that it costs $300,000 a year to do the printing which produces this outcome. Map printing is also required to support the data complete outcome, so we'll connect those. Notice the aggregated value now of the map printing action. It is the sum of the information outputs it supports. For the rest of the workshop, you continue to build the model in LINQ until you've included all the actions, information, and systems that are required from the first step to the desired outcome. Once all the modeling is done, the completed utility current state model will look something like this. You can see that we carried over the outcomes and we've got costs for each of the key information outputs, and we've completed the model, which starts from down here, from customer requests, through account creation, service validation, capacity planning, permit requests, and design until we get all the way to the desired outcomes. Also notice that we have all the link sets or groupings of activity collapsed so the model is more readable. To dig into more detail, we just expand all these sets like this or like this. We're going to introduce a new LINQ concept now called tagging. Tagging allows us to flag any node or link set in a model with a piece of information. Let's take a look at how that works. In this example, we're going to tag every system designated as paper with a high-risk tag. We can do this by searching the model for paper like this. Then selecting all the paper systems like this. Then in the tags property, we enter high risk. Then we have to turn the flags on in the visualizations. We can now see all the tags in the model. This by itself is useful in calling out areas that need attention. However, the real benefit is in the impact assessment portion of the analysis. Now, the power of LINQ is in the analysis, using the insights and the dashboards. We can answer questions like, what are my operating costs for this information flow? You'll be able to see what the impacts of people and systems are. In other words, what outcomes they support, what information they create, what systems they use, the impact of systems, how many are used, how automated are the processes, what percentage of the information flow relies on each system, those types of things. All of this establishes a baseline, and we'll dig into this types of analysis in another video. If you're interested, pull up the video, LINQ analysis, and take a look. Thanks for your time, and see you in the next video.